My name is Paul Fischer. Presenting with me is Jay McKay. We're from the Center for High Performance Computing at the University of Utah. And we're going to talk about how we approach effective compute resource utilization. So what do we mean by effective? From our perspective, there's three elements here. First of all, we want the utilization to be high performance. We're at HPC Center. Everyone has a laptop nowadays, so everyone can do computing, but not everyone can compute on a high-performance computing cluster. So we want to make sure that this utilization is leveraging HPC and they're getting their scientific research results in a timely manner. However, we also want to make sure that this utilization is efficient, broadly meaning there's not a lot of waste. So, anyone can use Slurm and request a bunch of resources, but that doesn't mean they should do that for their workload. We want to give a lot of these resources to people, but then we want to be able to monitor and evaluate if they're using things efficiently and shape behavior so that they get the resources they need and not much more than they need. There's different kinds of efficiency. We can talk about like GPU and memory utilization, compute utilization, IO, power, financial efficiency. For the most part, we're focused on the first two items here, compute GPU and memory utilization. But there's definitely plenty of room to explore the others as well. And lastly, we want to make sure that utilization is fair. Again, people can request lots of resources, but we want to make sure there's systems in place to make sure that those are distributed more or less fairly. So how do we do this? Well, we have requires a lot of data to have an automated system to enforce effective utilization. So this is a kind of high-level view of our architecture. We primarily rely on batch job metadata from Slurm and system metrics, which are just CPU memory utilization collected straight from the servers. We store those in databases, and then we feed those into our different analysis tools to produce reports and alerts and stuff. In a lot of these cases, we will email users directly, and in those emails, we'll provide more context about what we detected, how they could fix it, and then we always have our door open to helping them out directly with what they could do to fix these issues. So if you have any questions about any of these tiles, we could talk at length about each of them in the Q&A or afterwards. Our emails are in the call document. So now I'm going to head over to Jay so he can talk about what we're actually doing concretely to address these.
Yeah, so thanks, Paul. We have kind of two different models of resource utilization. There's the login node utilization and the compute node utilization. These kind of represent two sides to a similar coin. On login nodes, we want to monitor for overutilization. We don't want a user hogging the node. We want to notify the user they're doing this, and we also want to enforce limits. Right now, we do that with Arbiter, a project we've had for a few years now. There's Arbiter 2, and we're working on Arbiter 3. I'll just plug that. Where this monitors the resource usage using those system metrics Paul mentioned and aggregates and reasons over that data and sends an email to a user and then tells them that their resources have been limited. Here on the left, we have a picture of what a graph might be in that email. The email will explain kind of what they did. Here's what you used. You were supposed to use one core, and that's what that dotted line shows. And you went over it for a certain amount of time. We don't want you doing that, so we're going to limit you. You'll expire in a certain amount of time. And so this helps users know that they're using the login nodes poorly, and so hopefully they can fix their behavior. And we can also log these things and keep track of repeated offenders and maybe reach out to them directly if that doesn't help. But we've seen this help in the past with our login nodes becoming a lot more stable. A newer thing we've been working on is the utilization reports for compute nodes. This is for underutilization. So we really want the computes to be saturated at all times, ideally. We've noticed that a lot of jobs, a lot of users are not requesting the resources efficiently. Either they just don't know or they're unaware. So we've now begun monitoring exactly what resources a job is using during the job. Here we've got an example of what a user sees. We send them an email essentially saying, hey, your job is underutilized for this reason. Maybe they're using only one node out of many, or the CPU is slow, or their GPU is not being utilized at all. We'll notify them, and then they can go to a dashboard and see kind of, hey, these are the nodes you allocated. There's little drop downs on each of those to see what was actually allocated, how many CPU cores, how much memory, and what your utilization was. So in this example, a user requested 3 nodes, or rather was allocated 3 nodes, and they only used one of them. It's probably because their code can't, fan out to the multiple nodes. And so this is probably just an information issue, and we just want to make them aware of that, and so they can fix it and utilize these resources correctly. So, maybe request 1 node, higher core count, or refactor your code, things like that. So we do automatically send these emails now, and this is something new we've been working on.
Thanks, Jay.
Thanks.
So
Jay.
that's kind of our lightning talk. Again, our email's in the call document. If you want to ask any questions about our architecture, happy to talk about it. Martin Chuma is also a good resource. He's not on the call today, but we work closely with him on this as well. Thanks, everyone.
Yeah, and I would encourage you to use the chat, and if you guys can answer any questions that came up. And next up is John and Josko. Thank you. Welcome, John.
Okay, hi everyone. I'm John Halverson. Josko's on the call, but he's in an airport in Amsterdam on his way to vacation in Croatia. So we're going to try to leave him alone, but he may jump in.
Okay.
I'm going to use Paul's. Oh, here he is. Go ahead.
I was just going to say it's noisy over here, so I'll try to keep quiet.
Okay.
So, hi.
He's here. So for the same reasons that Paul just mentioned, you need a tool to monitor jobs for efficiency. And what we've come up at Princeton over the last 3 years is something called job stats. The central piece of that is the job stats command. So I will just grab a job ID and run that command. And this will give us an efficiency report for that job. And so at the top, you get metadata. Things about how many GPUs. In this case, it was 6 GPUs. In this case, it's still running. And then the second piece of information is the overall utilization, and it's sort of shown in a text-based graphical way. And so we can see the overall GPU utilization is 78%. That looks pretty good. And then if you want, you get the detailed utilization, which shows the actual host name, and then CPU time. It shows the memory usage and how much you allocated. And then you can see GPU utilization for each GPU, as well as the GPU memory usage. At the bottom, there's notes. In this case, there's no problems with the job. So all you get is this URL, which allows you to get more detailed information. So if I jump to a web browser and paste in that URL, it will load the Grafana interface. And then you can go through 17 different metrics. I think the first 4 that we'll see are for the particular job, and then the remaining ones are for the entire node. So if you want precise information just for your job, you have to run exclusively. But here you're seeing CPU utilization, CPU memory utilization, and then we have GPU utilization for each GPU, GPU memory utilization, and the list goes on. There's information about, here's the per node statistics. And so you get things like average CPU frequency, overall CPUs, and then it goes into information about the different file systems. So NFS, if you're using GPFS, here you can see the bandwidth. And then there's information about the networking, specifically InfiniBand and the InfiniBand errors, for example. Let's look at another example of the job stats command. And this job has a problem with it. And the problem is that it didn't use the GPU. And so here we're flashing it in bold red letters. And then we're telling the person that they really need to fix this before running another job. And there's something like 13 different notes to cover the different types of installation underutilization instances. In this case, the person allocated 16 nodes and only 2 cores per node. So we complain about that, and then we tell them how to understand the timeout failure. And then we also complain about the memory usage. This job only used 6% of the 128 gigabytes of total allocated CPU memory. And so that we tell them what settings to use for future jobs. We have a open on-demand app, which makes it easy to get job statistics. And so if we go jobs and then active jobs, one can see everything that has ran recently, as well as completed jobs. And so if you choose one of these, you can get some information about it. Here it's showing CPU utilization and memory utilization. And then if I were to click on the detailed metrics, you would get the Grafana interface. So let me tell you how this actually all works. This is the diagram trying to explain it. We have different exporters running on the hardware. So there's a node exporter, a C groups exporter, and for a GPU node, the NVIDIA exporter. And that's running, for instance, on a compute node. And then if you have GPFS, there's also a GPFS exporter. That information gets sent to the Prometheus database. And then you can use Grafana to look at the different metrics through the browser. And then we combine the Prometheus data with the Slurm data. And that's available through various command line tools. And the one that we just saw was job stats. One thing that's nice about our platform is that it doesn't require any user involvement. All the monitoring is done behind the scenes, and we sample at a rate of every 30 seconds. So towards utilization and making sure that people are doing things effectively, we have a tool called Job Defense Shield. And this is used for automatically sending email alerts. You can use it to create reports for system administrators, and then you can use it to automatically cancel GPU jobs at 0% utilization. This is an example of a report. And so if for some reason you're not canceling automatically and you just want to know who's wasting the most GPU hours at 0% utilization, you can run this report and it'll show you the user and then how many hours they've wasted. And then thanks to Jeff Avila at Brown, we have this nice feature of having a few job ideas so that people can see what exactly is the problem. If you want to catch the people that are wasting CPU memory, this is what the report looks like. Again, it's username. You can see how many terabyte hours they've not used, how many they have, and then there's some ratios and other quantities to decide whether you want to write to them directly, but you can also configure things to send the emails automatically. This would be what happens if you get your job automatically canceled. You can send a warning, and then depending on how you specify the time, the job just gets canceled and they get a second email. And then for someone that's wasting CPU memory, they get an email such as this showing the data. So it's a pip. This package can be installed via pip. And here are the different GPU alerts. We're going after GPUs at 0% utilization. We go after low GPU utilization. People that are allocating too much CPU memory per GPU, too many cores, if the GPU model was too powerful, and then if they're splitting the job over too many nodes. And then on the CPU side, again, 0 CPU utilization, people over allocating memory, low CPU utilization, serial jobs that are allocating multiple cores and wasting all the excess cores, and then fragmentation, and then runtime limits, just to give you a sense of what the config file looks like. You just specify the cluster, the partition, and then some settings. And that will begin to send those emails if you put it under something like cron. To finish, one very nice thing that we have is utilization policies. Thanks to our advisory group, we got these approved 2 years ago. And so if people ignore our emails, it's really not a problem for us because we have the authorization to cancel jobs that are showing 0 CPU utilization. And then if they're over allocating CPU memory, we can shut them down. And then also if they're allocating multiple cores for serial jobs, we can very quickly shut them down. If you want to hear more, we'll do a poster at PERC in a couple weeks. And lastly, the software is free and open source, and to get it all going, you just need one standard server for Prometheus.
Great. Thanks, John. And I saw a link was put in the chat, so if there's any other resources, feel free to use that space. And looks like you might have a few questions too in there. Thank you. And on to Julia Mullen from MIT. Thank you. And you are muted, Julie.
Sorry. So thank you for having us. I'm Julie Mullen, representing the team from the Lincoln Laboratory Supercomputing Center. And this is the entire team. This is our ops team and our every team. So we're pretty small. And I'm not sure how many people know Lincoln. So I just wanted to start with a quick overview of, whoops, too quick, of who we are. We are a federally funded research and development center for the United States government. We have systems both on campus at MIT campus and within the laboratory. And we tend to have at the laboratory users who will be users for years, maybe decades, but their programs change all the time. So a lot of the research and the work that people do for tuning and for performance, to improve in performance, doesn't happen as much for us. It's harder to motivate them to do that if they're only going to be working on something for 6 months. So we have had to find other ways to motivate that. So I want to start by saying we pioneered the idea of interactive on-demand supercomputing about 20 years ago, and we have a long history of abstracting painful details from our users. So I really enjoyed the last 2 talks because you have really abstracted it and given them back the information that they really need. We haven't quite gotten to where we have something with a beautiful dashboard, but what we have done is we have created a tool so that users can start to understand how they're using the system. So, classically, we've trained people how to tune applications, create a speed up chart, and understand where the bottlenecks are in their application. But in order to really get any sort of performance, you have to actually be using the hardware that you've requested. So that traditionally has required a sort of a deeper understanding. We were training people how to use HTOP and how to use TOP and how to use NVIDIA SMI. And we have a huge number of engineers who are happy to dig into that. But when you start having an application that's running over, however, as it scales out to many nodes, you can't log into every system to track that. It's just too tedious. So to overcome that, one of our team members created what we call LL Load, and it looks a lot like what you folks have already presented, and it's exactly for this, same motivation. Thank you for providing the motivation for why we need this. So what this is using is basically common tools, NVIDIA tools and Slurm tools, and parsing it into human readable format. Users can run this while they're running their job. So you can just, as you're running, you can just run LL Load and sort of see what you're using. And that way you can get a snapshot at whatever cadence you want. And so it calls out sort of how many nodes you are using. This is how many nodes you're using or requested. And then on there, how many cores you're using, leaving how many free, and then as well as your memory. What's your memory load? So you have your load and whether or not you're really using the system and the memory. The same is true for the GPU jobs. You can see that in the lower half there. You can look at the load for the cores, and then you can look at the load for the GPUs. There's a place where people have asked for GPUs and they're not using them either, and nor are they using the memory. And so what we do is we train people. We've built examples of what good utilization looks like, and we've provided documentation, and we're building out a micro learning module to explain that to the users so they understand how to use this tool. And for the team, what we're doing is we get a weekly report for the top 10 users with low CPU node hours, core load or GPU node hours, as well as those who have the highest core load. Because if you're overloading the node, you're probably tripping yourself up and you may be impacting other users, but you're really probably impacting yourself. And with regard to the low GPU node, we then reach out. These are the 10 people we're going to reach out to this week, and we're going to work with them to understand what type of, what their workflow looks like and how we can help them be more efficient. If they don't respond to us after a certain number of weeks, then we cut them off, and at that point they respond. So we haven't got a policy as well defined as the one at Princeton. So other people from the team who created this are on the call, so they can also answer in the chat. So thank you very much for having us.
Great, you are right on 5 minutes. Thank you, Julie. Great work. And next up, we have Amit. Take it over.
Can you see my screen?
Yes.
Okay. Let me make it bigger. Oops, it's going on the other screen. Sorry for that. Okay, let me just present it like this. My name is Amit Ruhela, and I'm a researcher and manager at Texas Advanced Computing Center. And this presentation is regarding our tool at HPC PowerStat. So TAC in nutshell is basically founded in 2001 with a goal of providing the supercomputing facility, especially the HPC, to all the research happening in the United States. And currently we facilitate 4 main systems, which are Frontera, Stampede 3, Lone Star 6, and Vista. Altogether, we have 12,000 nodes, 1 million CPU cores, and 1,000 GPUs. And we provide resources to 3,000 projects having 40,000 users. And in monthly basis, we receive 60,000 jobs on Frontera, 52,000 jobs on Lone Star 6, and 90,000 jobs on Stampede 3 per month. So as you can see, there are a variety of systems, 3 different architectures, Intel, AMD, NVIDIA, and then we have 2 different interconnects, OmniPath, InfiniBand, and then 3 different file systems, VAST, Lustre, and BGFS. So as you can see, the HPC systems are complex. They are constantly changing, and optimizing any application, one system or one variety of systems, is really a complex task for all our users, and they seldom apply the optimizations possible on a given systems, and they constantly look for what can be done, why the problem came, and how can we solve the issues. And to give some of the ideas, like how the users can find out their issues themselves, or maybe through the consultants like us, we have developed a HPC PowerStat tool, which was previously known as TechStats. And it's an open source tool, downloadable, configurable, having a generic Linux-based, configurable on all the Linux-based architectures. And what it does is similar to the tools which provided by Paul and the others before Jonathan. So this combines the slump statistics as well as the job matrices collected from a variety of nodes, and provide all of them in a consistent manner over a web portal. So what we collect are basically the system log, process statistics, memory information, paging statistics, IPC counters, file system usages, interconnect traffic, core counters, and energy counters from the RAPL library. The common use cases for us are like this. The first use case is the job status. What are the jobs which have, what are the jobs run by all kind of users on our systems? What are their statuses? Why they fail? And then we also provide, like, this also tools can be used to provide the job history, like how many jobs were run by a user, how many have been successfully executed or failed or pending or whatever the information, job status information. So this helps us to build a support context. We can look at the jobs executed by user, their previous history, and the current job information which they provide us. And then this also helps us to identify the application behavior. Looking at the various statistics in all sort of ways help us to identify which could be the bottleneck, why the application failed, why there are memory, what are the memory uses, why there are memory out of memory errors. So we can see how the memory was going when the application was starting and when it was failed. This also helps us to analyze the cost estimation of the resource usage, like the SUs. And finally, through the Splunk logs, we can provide the logs collected over a given node or the nodes or which the jobs executed on the given system. Architecture-wise, it's pretty simple architecture designed a couple of years before, not very sophisticated. It has, as you can see, there are login nodes and the compute nodes. On every compute node where a job is running, there is an executor script running, collecting the information when the job starts, when the job finishes, and at irregular intervals. And all of this information is being sent at a regular interval to a Access server, where we have a RabbitMQ data pipeline, and then there is a timescale DB. And all this information is then displayed over a web server. So these are some of the screens which I would like to show. As you can see, for a given month, a user can see what are the jobs run on a given system, how long did they run, how many nodes did they consume, what was the average wait time, like queue wait time for any job, and then what was the file system operations like open and close on an average. Instead of this, let me show you something from here. This is visible, the TaxApp machine server. So on this web page, as you can see, these are the top 10 Lustre jobs which have run in the past 5 days. You can see all the jobs run on a given day. These are the users who have run the jobs, these top 10 Lustre jobs. Then on the next screen, we can see some of the flagged jobs by our system. For example, these are the users who have used the highest metadata request. These are users having highest memory operations, node imbalances, time imbalances, and high CPI, which is cycles per instruction. Then all of these jobs are listed here. Their information is presented. And once you click on any job, you can see a variety of statistics. For example, the job information, starting time and ending time, which queue they ran it, how many cores, how many nodes they have been using. And this is a high-level plots for a given job. But apart from that, there are 20 different variety of job statistics like block, CPU, InfiniBand, switch counters, then memory, MDC, and all. So these are the various kind of statistics which we collect and provide to the users. And then there is another system level plot which shows how the job was dispersed over the racks and compute nodes. For example, the x-axis shows the racks and the y-axis shows the node within a rack, and this shows where exactly the job was run on a given system.
Amit, you are at time, so.
Yeah, sure. I'm just done. So I just wanted to show that these are the screens which we have collected, and yeah, that's all. I'll be happy to take questions in the end.
Yeah, and then also if you can share that slide deck with me, I can get that out so others can get a hold of it. Thank you very much.
Yeah.
And on to Joseph. Thank you.
Okay, give me a second. We just have to wait for Amit to stop sharing.
There you go.
Oh, all right, let's see if we can operate this computer. Dink. Right, hopefully you're seeing the full slides.
Yes, looking good.
Cool. So, hi, I'm Joe White from University of Buffalo. So I'm going to talk a little bit about XDMod. So XDMod is a piece of software we think of as like a comprehensive framework for CI system management. So it actually supports, it's a data warehouse plus various tools to get data into it, and various visualization and data analysis tools. And it's specifically designed for like cyber infrastructure resources, and supports a wide variety of different data that you can load into it, of which job performance data is one of those things. One of the benefits is that we can, if we pull in data from multiple sources, we can associate them together. So you can pull in things like job performance data with your metadata about the people, what organization they're in, what group they're in, and use that to enrich and learn more stuff about what's going on in the system. OpenXDMod tool itself is open source, and we know of at least 400 installs worldwide where it's being used. You can go to the website, download it, install it at your center. We also use the tool for monitoring the NSF funded access cyber infrastructure and the NAIR project infrastructure as well. So specifically to talk about sort of job performance and job efficiency measurements in XDMod, just highlighting a few of the features. So XDMod tool itself doesn't do the data collection, so we integrate with existing open source tools. So I noticed a couple of folks here are using Prometheus. Again, we can make use of the Prometheus node exporters and take that data and load that into XDMod. We also support Performance Copilot, which is a well-established open source tool. And we also support HPC PerStats that Amit was just talking about. So we actually gather the data from the tax systems and load that into the Access XDMod instance. The main things that XDMod gives you is that it has integration with your single sign-on system and role-based access controls. So users can, if you integrate this in your center, users can log into the web-based portal with the same credentials that they log into the normal system, and then you as somebody in control of XDMod can control exactly what information that they can see, plus so not only restricting what information they can see, but how the data is displayed, so they can view information that's pertinent to them. We have an integration with On Demand, which we'll talk about in a second. And there's a wide variety of different features available in the tool to allow you to view the historical jobs in aggregate and also individually in order to understand job efficiency. A couple of examples of that would be when a user logs into the tool, the front dashboard that they see has a panel showing their job efficiency report with a categorization of whether it's good or bad, and they can click on that and drill down and view all the job information. So PIs can see the information about all of the people in their group, users see their own jobs, but also support staff can log in when they see a view of everybody running on the system, and they can use that to proactively identify people that need assistance and help. One thing I will point out that's sort of distinct from some of the other things that have been done here is that XDMod is really optimized for historical data analysis and long-term analysis, aggregating large number of jobs together. It's not designed for real-time analysis. You'd probably use something like Grafana or one of the other tools that's been talked about here for doing that. So a couple of examples of some of the efficiency identification tools that we have. So I mentioned earlier, there's a efficiency dashboard, so that when somebody logs into XDMod, first thing they see is a breakdown of the jobs that they've been running, broken down by a categorization. Again, PIs can see everybody in their group based on the access controls. Users can see their own job information. They can click on that, and then that takes them to what we call a job viewer, which is a detailed breakdown of all the information we've collected on a job. I guess one distinction is it's not just the performance data, so it's other things. You can integrate it to tie into pull in the job batch script information and have that embedded in the interface as well, so you can see that. All the information about the accounting data and allocation information can also be presented alongside the efficiency information. Then for support staff, we have an efficiency tab, which shows basically this little screenshot on the top right here shows the high level view of the efficiency tab. The way it's structured is we have several different efficiency metrics, very similar to what was discussed earlier, CPU usage, GPU usage, and then scatter plots showing each dot on the scatter plot corresponds to one person's usage. And the way that we do it is on the y-axis, you've got the amount of usage, and then on the x-axis, it's whether it was efficient or inefficient for a given measure. So it's very easy for support staff to say, well, anybody who's in the top right of this plot is heavy users of the system and they're not using it inefficiently. And you can click on that, and that takes you down to another view, which allows you to drill down and get all the information about the user. We also have some aggregate metrics and analytics that you can do using automated tools that are available as well. Roughly, we sort of do the efficiency characterization by two different ways. Talk about CPU usage, memory usage, GPU usage. But you can also do filtering and analysis by things like, how many short jobs is the user running. So if somebody exclusively runs 2 or 3 second jobs, on a batch computing system, that's typically not an optimal way to run it, so that you can identify things like that. And then also identify stuff like, you know, people using large requesting more wall time than they actually use. Again, like an efficient way to use a batch computing system is to make use of the is to request what you need. Very finally, so we have an integration with the Open On Demand portal. The screenshot on the bottom right here shows the portal running at CCR. Basically, when users log into the On Demand portal, they can get like a little dashboard which shows similar information that they would show if they log into XDMod, showing their historical job usage with the efficiency rankings. They can click on that, and then that takes them to Open XDMod to show a view of all the job data. And I'm already over time, so I shall stop talking.
No, you're doing great. If you had any other points you need to make, we can have time, but
yeah, just one thing. I saw there was a question in the thing about, oh, has stuff changing over time? And one of the advantages of collecting all the historical stuff in XDMod is it allows you to pretty easily see changes over time, because in our aggregate view of the data, you can do things like plot, you know, mean CPU usage over time, groups by different mechanisms, so you can see if you do any interventions, have they actually worked.
Great. So now we are done with all of our presentations. We have 72 people on this call. Thank you for being here today. We have 5 great groups or panelists here. So please, if there's any questions, folks, feel free to raise your hand, use the chat again. Julie, I saw you were responding to some questions in there. Did you have anything you wanted to highlight?
No, I was responding, and I'm gonna. There are a number of folks from Lincoln that are on the call, so feel free, folks, to jump in, because you've also been working with this on the back end. One of the questions that I thought was really key was, are we seeing a change in user behavior? And so I wanted to point out that we are. We don't have, and the level of seriousness in terms of the usage or the misusage of these resources, we haven't seen anything really serious. We've had some users who don't respond, and so they got cut off. But for the most part, it's generally a misunderstanding by someone who is either new to a group or is trying to do something. And when we sit down and talk with them and better understand what they're doing, then we can explain to them other alternates that they can take. And it makes everything more efficient for them. So they're more than happy to make those changes. I don't know what other people are seeing, their sites. I'm curious though.
Well, Jonathan, John, did you have any thoughts that you wanted to add to this discussion?
So we find it hard to quantify. I know in 2023, we lost 30,000 GPU hours at 0% utilization. And then we doubled our number of GPUs after that. So maybe we would have lost 60,000 each year after that. And like Julie was saying, some users ignore the emails and you have to chase them down. I'm sure that what we're doing is effective. I just find it hard to give specific numbers about it.
I'll add to Julie's comment. I think having metrics and showing the user what we're seeing often it puts them into a rather collaborative place of like, oh, I didn't realize, or I didn't even know that I didn't have the GPU, or yeah, I was kind of running slow, but I didn't want to bother you with helping me diagnose it. So there's a rather than coming at them with, well, we think you're not using the resources well, but having metrics really gets the conversation going and has a conversation about the data and how they can improve, as opposed to kind of a more defensive posture.
Great. Katya, I don't know if you have seen anything in the chat that you wanted to highlight.
I have a question of my own to the presenters. So we do have our own system of checking utilization, specifically GPUs utilization of the users, and we what we found that there are some cases where the GPU, the users use, it's not their code, it's they submit some application. And I think one example was AlphaFold, where utilization is very inconsistent. It could be it uses for a second, then goes down, does not use, and then it again goes up and down very, very sporadically. And so we are not using Slurm, so we do not have a continuous data. What we do is sample. And so our sampling happens, once a minute or once a couple of minutes, and it misses those spikes of utilization. And so in 2 hours, if it does not hit that spike, we say, okay, you are not using GPUs. So I wonder what those people who implemented their system do with those jobs. Are those jobs considered to be also ill using resources, or they are fine on your opinion?
So I mentioned this in the chat. Sorry, Paul, just be very quick. And that is that as people start working with LLMs, it's very bursty, right? They need to reach out to it, but the LLM needs that memory. So I don't know how we're going to move forward with that. I'm looking forward to hearing what other people have to say.
So for
I'll
that,
add that. Oh, sorry.
please continue.
I'll add that, like, it's a difficult problem when for a lot of the metrics we collect, we're sampling. Some of the metrics are expressed as counters, and those are really valuable because we can be sure that between 2 time points we are capturing every utilization. But for things like memory and GPU utilization, it can be more tricky, especially the NVIDIA GPUs. We sometimes have trouble getting access to useful performance metrics there. They might just give us out of 100%, how much is the GPU utilized at this moment? And that's not a terribly useful metric. That is what we're using right now, but it can certainly miss spiky usage. I think we're only sampling every 30 seconds, so can certainly be misses in there. As far as the memory goes, I think there's some capability in like Linux cgroups v2 to like capture like the memory high watermark for a job. So we're interested in looking into that because that would address the memory case where someone might only be using 1% of the memory over time, but they used 100% for one moment, and we don't want to prevent them from doing that. So yeah, it's a difficult problem, but it's an interesting one.
So from that perspective, these jobs are like the performance metrics which we have collected. It's the job sensitive. Some of the jobs have very large spikes. Some of the jobs have regular spikes or whatever. But we don't care for them because the nodes are allocated exclusively to the users. We care for if they are using or misusing the file system accesses because that is what is shared across all the users. So if file systems they are using extensively, we ban the users, we turn them off and ask the experts in the background to look for the job inefficiencies or whatever the way how they are running the jobs, whether they are doing IOs per process or whether they're doing IOs per node or all those systems like Romeo library and MPI, which helps to optimize the IO accesses. So memory, GPUs, we don't care a lot. We care like if it hasn't been used at all, but if it has been used for some amount of time, that's perfectly fine because some of the users are even building the jobs, building the applications over to the GPU node. Sometimes the login nodes are not like have some issues. So they do initially started building on the GPU resources. That's perfectly fine for, yeah.
At Lincoln Lab, what we observed was that some of the users actually not familiar with the scheduling environment. So people just inherited scripts from other users, and then they just use it. And then some of the low GPU usages resulted in not understanding the options, Slurm options that they are actually using. So in that case, when we look at both JavaScript and for those low GPU uses, we quickly identify users that they are using wrong options. So in those cases, it's easy to fix cases. Other cases is that some applications are not paralyzed to use more than one GPUs, but they are still allocating multiple GPUs, which also causes inefficiencies. So those cases we also quickly identify using error load weekly analysis. So we notify those cases. We are able to do that by just saving users' JavaScript, so we can quickly go back to what JavaScripts they used when they submitted job for those poor jobs with low GPU usage.
Great, we probably have time for one more question. If
There's been a question in the chat. There are actually two that related to what this means in terms of extra, where am I finding it? So Jacqueline and Julie both mentioned trying to understand what the workload is now for the researcher-facing staff. You know, how is this impacting that? Since I've already answered in the chat, I'll let other people speak. I'm just bringing the question up.
Thank you.
For us at CHPC, maybe Jay wants to chime in on Arbiter. I think that has been an improvement for us because previously with login nodes, you know, we had sometimes utilization would just get really bad and people would complain about the node being slow and we then have to investigate it. But Arbiter, I think, has cracked down on a lot of those issues and made the resource more consistent overall and require less intervention.
I
Yeah,
think for,
I'll
sorry,
go
go ahead.
Oh, I was just going to say, as far as the job utilization increased workload, it's still too soon to tell. We've only been running with emails for a few weeks now. We've only seen a handful of tickets, like, what is this? So the workload hasn't increased much, but it's still too early to say if it's going to increase or decrease overall.
I think at Princeton with job stats, we probably do put more pressure on the people doing the help sessions or consultations. And we do have a sentence at the bottom of the emails we send out saying that they can reply to open a support ticket. So you do, I think you do get elevated tickets due to the monitoring and contacting the users and more pressure on the help sessions, but I think it's worth it.
Great, thank you everybody for being on this call today. I will get this call recording processed. I will take the lengthy chat that will come with that recording and I'll move that text into the call document and get that published. So I appreciate the panel today. It was a great conversation. I posted in the chat where you can find the CARC community at PERC. So I will not be able to attend that, but I hope I'm sure many of you will be there, and please hit our booth and say hello. And great to have everybody today. Thank you so much for being here.
Thanks, everybody.
Cheers.
Thank you.
Thank you.
Thanks, Joe. Thanks, Julie. Paul.
Oh, you're welcome. Thank you for inviting me.
Yep, John. Thank you.